think about the fact that for everyone on Earth, the sun rises from the ground. And then think about a ball. Why does the sun never rise from around the side? Why does it never come from the right? Why does it never come around the side of the ball? How could it be from everybody's feet? Well, it's because this is what we're seeing. It's always rising from your feet. One thing you can do, the sun is never, ever below your feet. Ever. Not for once in one moment, never, never, never. The sun is always above your head. Every second of every day, the sun is above your head. Now, if somebody asks you, well, why can't we find it with a telescope? This is the one that Zach, I was going to say Galifianakis, but I'll show you these and then we'll get into that. Let me write that down so I don't forget. Well, I'll tell you right now. So Zach kept saying the reason he ended up going off on flat Earth and saying that it was stupid is because he couldn't grasp the idea of why you can't see the sun with a telescope if it's far away on the other side of the Earth. And it's because this is the kind of thing that science or teaching or whatever has done to us that you don't get that if you're looking, and again, I'll just do this, if you're in a big bedroom or somewhere and there's a light on top of it and the bedroom is as big as your city, that if that light started going across to the other side of the city, say it went 5 miles across, pretty soon you're no longer going to see it from your spot in the room because the ceiling hits the floor. Okay? And when the ceiling hits the floor, anything past that is out of anybody's sight. You could bring out a telescope all you want. You're going to just see into the end of your sight. You might see a little further, but you're not going to see all the way. And if you think of it that way, that's why things on the ceiling, okay, as they go down, they get occulted from where? You know, if they're going down, which way would they get occulted from you? Same thing with things on the floor, right? If somebody's walking away from that room, you're in that bedroom, 5 miles long, somebody's walking away from you, well, the first thing that's going to disappear is their feet. As they walk away and they get 2 miles away from you, you're going to see that they start to disappear from their feet up until pretty soon you're only going to see their back. And then you'll only see their head, and then they'll be gone. That's everything that we have. That's why I know science is full of shit. That's why I know that and I don't want to say science, that's why I know that people who have trapped citizens, that's why I know these guys who are NASA lovers, they won't admit what is clear and evident. They'll keep going on with these same beliefs that they've had their entire life. You can believe that the boat goes behind the curve. It does not. I've already proven it to myself. You can still keep believing in lies if you want. That's not my business. I'm not going to beg you. You can believe in lies all you want. What do I care? This is a time-lapse footage from the other day. Miss and I went to the beach to do a laser experiment, and the weather was shitty. As you can see, it's like all gross around the whole entire edge. But we ended up doing a time-lapse of the sunset. This is from Monterey Beach. Actually, it's a little bit north. There's Marina Beach. And so we watched that. It was awesome. But I want to show you something cool here after this one. But it was very cool. And again, this is the sun going around my head. It's gone around me. It started out, east. It went around me, not above my head. We never get the sun above our heads where we live. And it goes around us, and this is it setting. And now again, is this the sun setting like we've been taught? Use your head, and this is the sun getting smaller and going away from you. Watch. Clearly, the sun is going away from you. Clearly. If you argue with that, you argue with reality. Clearly. Watch the sun. If you think that the sun is setting like you were taught, like a big ball over the water, then you lie to yourself. You're lying to everyone else. And if you think like Jason Awake Souls, who is the biggest asleep person I've ever saw, he was looking at the sun the other day that was about like this high and some clouds, saying he saw clouds behind it. Ridiculous. But he said, this sun is only 3 miles away. 3 miles. And that guy wants to call me a deceiver and a Satanist. 3 miles? The sun moves 1,000 miles per hour. Okay? Give or take a couple hundred. 1,000 miles per hour, meaning if it's above your head at noon, right above your head, that's noon, and it's above your head. So then at 1 o'clock, it'd be 1,000 miles away from you. Think of where the sun is. At 1 o'clock, it'd be still above your head. 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock. He's looking at a clock at like 6 o'clock, which means it's 5,000. I mean, he's looking at the sun 5,000 miles away, saying it's 3 miles. What a joke. What a joke. If people can't choose who to listen to, give me a break. That's for you Russian vids. Give me a break. So yeah, clearly this thing's going away, and let me show you proof as we get closer here. So that was from the tripod with the GoPro. And now we're going to look at these are some pictures here. Okay, maybe I can get an actual better first one. Let's see here. Yeah, so this is a better first picture. So this is as the sun was getting close to setting. Something interesting here. This is a sunspot. See that little dark spot there? Okay, hopefully you can see that. It's a sunspot, and we didn't realize that at first. We couldn't see it. I couldn't see it when I was taping. I got home and said, "What was that?" And then I looked it up, and sure enough, it's a sunspot. So as it gets lower, the sun's going to start dropping. Now you're going to see something interesting. See this line here? This line here is the water. Okay. Now that might sound crazy because you're going to have to see how far away we are from the water. But that's the thing that people don't get, and that's how I know science is full of it. Let's go to this one. Okay, this is its even further setting, and you'll see we're getting a little bit of a Fata Morgana here, that it's reflecting off the top of the atmosphere. But look how far away from the water line this is. This is 100 miles or further that we can see the water here. This is how you know everyone that's been telling you live on a ball is full of shit. Because this line is not the end of the earth. This line is not the end of your horizon. It's the end of your ability to see. And I'll prove that to you right here. So again, how do I know this? Because this is the water, and this is the atmosphere. See this line right here? This line here is the atmosphere of the sun. I mean the atmosphere of the earth. It's that extra layer that I was trying to tell Wolfie about that made his things hard to see. And look what happened to the sunspot. It doubled. Okay, so the sunspot was single here because look at, here's this green line, which is the atmosphere. It's running below that. Here's the blue line, which is the water line. And then as we keep going, I lost it. Where'd I go? Okay, as we go a little bit further, as soon as we get past that atmosphere, it's doubling. Okay, you're now looking through a lens. It's multiplying. It's doing weird things. You can see the water line is here. This is a reflection of the sun. Okay, and let's go find this picture. Did we ever do this one? Yeah, we saw that one. That was above that. This one. The doubling. We saw that one. Just trying to see what else I have here. And I'll show you this video in a second. As soon as I finish showing these pictures, I'll show you that video, which is pretty cool. Except for I was mad because as it got to the very last second, and I was trying to catch what they call the green flash, I didn't get it. It was too hard to hold the camera. The GoPro was on the tripod. I couldn't get it. So there you can see I was a little further out. Let's see where this picture is. This one? So, okay, this picture is a great one to look at because that's the water line. Okay, so if you picture standing back at the beach, you're looking all the way out. This water line here, they're telling you is the curved earth. But the sun goes behind the water line, which is way, way, way back here. Now, the water could go who knows how far. But it's if you're on a flat plane, and also I wanted to show you that, but I'll do that after. If you're on a flat plane, it's not going to go up here. It's not going to go all the way up here. It only can go to your eye line. Now, those guys will go out to the beach and they'll measure. This is what geodetic surveyors do. They go out and they measure this line. And they say, the earth fell 3 feet in this distance or 12 feet in this. Whatever it is, they're lying to you. They're lying because they can't see the horizon line. So this whole thing, I don't know how far the deception goes. I don't know who is perpetrating it. But if you teach people to measure to the horizon line and say, what's the drop? Well, they're going to come up with a drop because you're not looking at the actual horizon line. I actually have a paper that was peer-reviewed and everything. A guy wrote that says once you're like a mile out and either 100 feet high or a little bit higher, the horizon is indecipherable. It is impossible to say where the horizon line is. Because like here, we wouldn't know. Maybe you could say it's here on the sun, but you couldn't measure it. It's too far away. So we'll go a little bit here. Oh, there's that picture there without the line on it. So you can see that the sun, you're getting in the reflection, a little bit of reflection, and it's going down in this little area here. And again, it's not going down. It's kind of the way you have to describe it. We know the sun's not setting. The sun is above my head. The sun is above everyone's head. If this is in Hawaii, remember, Bob's over here in Hawaii, the sun is above his head. But to me, and I'll actually draw you a picture David Weiss draws, which I think helps with that idea. So I got two pictures I'll draw you in 1 second. And I'm just going to see if I have any more pictures in here in that video. So this kind of showed, we saw that. And let's see here. I want to make sure I show you anything else in this batch. What's that one? I do with this one. Oh, this is just showing basically, you can see the water line now right here, right? This is the limit of the water line that we might see. But the water line is back here. So when boats are said to go over the curvature, it's a joke. What it means is that the boat has gone past your line of sight. This is your line of sight. Everything on the roof can go further, right? The sun is on the roof. I call it that, the ceiling. But a boat that went past here would start to disappear from the bottom up. You start going this way in a boat, when you get here, the bottom of the boat is going to become impossible to see. It's gone past the line of convergence. It's a disgusting mess. And then, but you can still see the sail because it's the furthest thing on the boat from the convergence line. So let's see here, making sure I don't have any more pictures I didn't show. Now we're watching it. Okay, there we go. So you can see there the sunspot right in the middle there. And I believe this video is super long. Yeah, this video is, it's only 7 minutes till it was gone. So you can see here, if you're looking carefully, the bottom here, excuse me. Let me zoom in a little bit for you. Actually make this a little bit better. See this? Nope. I want to go 1 second. I just want you to see a little bit better. This one, and I'm going to zoom in a little bit. Let's go closer than that. And even bigger. And even bigger. Alright, now we can see really close. There, and let's play that one. Okay, so you can see that right here is where it's hit the water. And this is a reflection. Okay, you can see that it's already hitting the water. Again, it's not the sun hitting the water. The sun goes down on the ceiling behind the water. And I call it a ceiling, but it's the sky. And anybody who argues with that just needs to go outside right now and tell me what's at the horizon. The sky. Now, the sky isn't that low. If you see clouds there, they're still 10,000 feet above the person's head who's standing at the horizon. Thank you very much. Thank you. I'm going to get to your questions at the end. So, let's see here. So you can see there you get the definite melting here at the water line. Now you can see the atmosphere line. See this atmosphere? And when the sun drops below that, you're going to get a reflection of the item off that. Again, this is just from your perspective, and again, it's also a reflection. And again, this is done with, I turned down the, I don't know what it's called, the EV, I think it's the exposure, and I went to all the way so it's the darkest possible. Obviously, this is not what reality looks like. It'd be like me telling you that clouds are going behind the sun or something. It's not what's happening. But you can see here what is happening, where this water line ends. And we'll get forward a little bit more. This is me trying to zoom in even more on it. It was really tough to hold it there. But it really just shows you where the water line goes to. And then you can see it start reflecting here in a second off of the atmosphere above it. Again, it's all above it. It's all reflection. See there? It's reflecting off. But you can actually see here it's like a football. And then that's where the water line is. Okay, so you see this is a reflection off what's way up in the sky from your perspective. Then you'll get a little doubling here. Oops, where is it? Did I miss it? Let me go back a little bit. And I really apologize about my filming. Like I said, the GoPro was doing a time-lapse on the tripod, and I was trying to zoom in way too much. It was too hard. And I was trying to get this green flash in, and watch me miss it. I was so pissed. And then Miss had to come up to me after. She's like, "You didn't get it? Oh, why did we even come?" I'm like, "Come on, I did the best I could." And then I think I look at some boats out here that were getting trashed. And so you see it was really ugly, gross out there. And let's look at these boats. Yeah, it was really bad weather. It was supposed to be nice, but then these boats were out there all getting trashed. And I guess they get together. One guy was telling me, I was talking to him, he said when it's going to be a stormy night, they all gather together because this way they don't get lost at sea or something. So they hang out so they can stay close to each other's lights and know they're not drifting away. All right, so that was that, and I want to show you this one more time because we can zoom in on it now that we've done that. Where's that other video? We're just going to show that other video where the sun was going away so you can see where it's setting. I'm going to get to that questions in one moment. What is going on here? Where is that other video? Not that one. That one we... Hopefully everyone remember... Yeah, you guys understand that with a curved or the impression of a curved atmosphere that things are going to render differently like I showed with the light. And I'm just looking for that other video. Yeah, this one. Yeah. So an interesting thing to do here. Oh, good. I did it. That's even by accident. So now I covered up the ground, right? Now remember, this video is of the sun being stationary and you falling backwards. Somebody's told you that and you believe them. That's what everybody believes who believes in the globe. The sun is stationary. You are falling backwards. Head over heels, backwards, and that's why sunsets happen. Could it be any more clear to anyone that the sun moves in the sky? The sun moves. Not you. But people want to believe in men. They want to trust men. They want to trust scientists who have nefarious reasons. So I'm going to zoom in even closer on this. Let me pause it. Okay, there we go. How big is that? I would have liked it a little bit bigger, but it'll work. All right. And let's play from there. So as you watch the sun set, remember everything we've been taught about what's happening here. We're falling backwards. The sun is setting. No, clearly the sun, now it hit the water, and now it's going away. There it goes. And you can still see it, and now it's gone. So, again, I'll play that one more time from about there. And like I said, if you have questions, I will answer the super chat ones, and then I'll get to the other chat if I have time, and we'll answer them out. Let's see, did I cover everything? So why I'm an AE believer? Well, oh yeah, I want to show you one other thing about that. Jeez, I didn't even go there. So I'll show you one other thing about the AE believer, and then I wanted to draw some things. I don't remember what now. Let me see here. Okay, so we're done with that. Let me bring up this other image, and we're going to go to overlay with paint. Here we go. All right, so I brought up this map here. So one of the things I wanted to talk about as far as, the picture David Weiss draws, I'll start with that. He's drawn this for me too many times. And let's see. All right, so what he draws is a picture where if this is the ground here, and you've got a person here, and a person here, and you've got clouds. We know the clouds are above my head. The clouds are above his head. Okay, but say he's a certain distance away, and to him, the clouds are always 10,000 feet above his head. To me, same thing. And the sun is here. Okay, I see it rendering through right there. Now, as the sun travels this way, okay, we know that our horizon, from our perspective, ends up like this. Okay, because the clouds, we see them meet everything at the ground. If you looked off into the horizon, everything meets at the ground. And that's really what we see when the sun sets, is you're kind of seeing that circle occult this. As crazy as that sounds, it's probably one of the better descriptions of it. Because really, if people say, well, the sun's not dropping, what do you mean by the sun's dropping? Which it's not. The sun isn't dropping. So, why is my mouse not working? Here we go. So let me show you another drawing here as an example. If the sun went below the earth, ever, you would be able to have the earth here. Okay. If the sun was really dropping over here, or we were spinning, causing the sun to drop, then you would be able to have a house that's on a, let's get a better color than pink for a house. Okay, let's say this is a mountain here. Again, this is not to scale by any stretch. Here's a mountain. On top of that mountain is a house. Okay, and at the top of that house is a window. Okay, then at many times it would be possible to have the sun below your feet. Again, it's way over this way. We know that. I'm not drawing to scale. But you would have rays of sun that could enter into the house going up, hitting the ceiling. Somebody find me any evidence of any sun ray hitting the ceiling of your house. You can find them all the time coming in. You know, you can always find sun rays coming into your house. But you will not find any sun rays on a ceiling in anybody's house, on any mountain, anywhere on Earth, because it won't happen. Now you can find them in the sky because those are crepuscular rays, and they can be anti-crepuscular, which again is just rendering onto the ceiling. I don't know if anybody knows it. There's actually a formula for the curvature of flat Earth, and the equation, which a lot of people don't know, is actually 0 times the distance squared. So let me do a couple examples. Like if you're looking 3 miles, it would be 0 times the distance squared, so 3 times 3 is 9, times 0 is 0. Okay, so that's how you do that. That's the curvature of flat Earth. So remember this, 0 times distance squared. And it even works, I know the real one doesn't work over 100 miles. Ours does. You could do like 4,000 miles on a flat Earth times 4,000 squared. But now you should know by now it's just 0. So isn't that easy? 1 mile? 1 mile is easy. It's 0. All right, just making sure you guys knew the formula in case anybody didn't know. It does work on the whole Earth. It's not like other formulas that only work for short distances and that kind of nonsense. All right, so now what we're looking at is Adelaide, Australia. And can I go back to where my map was? That would help me. Come on, map. Yeah, good. So we, again, I'll make this easier so people don't complain that I was talking about the wrong thing here. Let me spin this around. All right, so we're here. So from Adelaide, which is, and I don't know if I'm in the exact right spot, we'll just say here. Okay, so people think, I won't mention names, goofy people, think that the sun is doing this for some strange reason. They think the sun goes like this for these people, and the sun goes like this for these people, and the sun goes like this for these people, or this way. Which is not the truth. It's just how things are perceived. Again, if the sun is coming around this way, okay, coming around like this. Sun goes like this. From this person's perspective, with the sky that I've already explained how the sky works, that you would see the sun coming as kind of from your east, and I guess it's easier to draw a picture really, but from your east, let's say we're looking out towards the north, like we're going to be here in a second, that the sun is coming from this direction around, but of course things have to rise, right? And then things have to set because of distance. So let's go see what we see when we look at this Google Earth again. Okay, and we're going to look from here. Now watch this view that we see from here. I'm going to try and fast forward this thing a little faster so we can see it go. And we're going to look up higher in the sky. All right. Now watch, and you should get the picture of it. And you're going to see as this thing flies through, and I want it to go lower, so I'm going to wait till the summer here. So right now it's going above our heads. It's coming up from the east. Remember, we're looking north here. Oh, shoot, you don't go back that far? Okay, we'll go backwards. 1 second, let me get all the way back to the summer, because I need it to be low enough. Okay. So, shoot, I have to look up even higher? I'll go there. Sorry, now I'm getting to questions. 1 second. Okay, so as this thing's coming here, you can see what the sun is doing. Okay, from this perspective, it's coming from the right, from the east, and it's going off to the left to set. Now, if somebody turns and watches the sun, okay, so we're going to keep, let me break this down a little closer this way. Okay, so now you're watching it, and you can see it start to curve around. It's going to go curve around. There it goes. Oops. It went too far. There we go. There. We're going to lower it with it. Okay, so the sun looks to be setting that way, right? We know in the south it goes this way. It's just because that's how our perspective sends it. The sun is going and then out to the right. Meaning if we... Okay, you can hopefully see what I'm doing here. Can you see my mouse? Hopefully you can see my mouse. I don't know. Well, if you can see my mouse, it was coming around this and it's going around that way. But from your perspective, because everything renders in your general area, we know, for instance, you can only see, 3 miles to land? Is that what they say? 3 miles. And so, the sky, we know we can see from much further than that. We can see the sun because it's bigger. I mean, I have no idea how big the sun is. I know Robotham and those guys said 32 miles. Well, imagine how big 32 miles is. That's huge. Some jackasses taught us that the sun is 899,000 miles across. And that's a lie. The sun is, it's not that big. It's not that small. It's probably the biggest thing any of us have ever seen. No one's ever seen something 32 miles in diameter. It's like, that's huge. It's ridiculous. You couldn't even imagine it. So something that large, which is rendering that large, it would come around, go this way. So again, you can just kind of watch this as it flies through. And let me look up this way. Maybe I'm not all the way on the ground or something. Let me see. Usually, yeah, I'm way up in the sky. That's why. All right, let's get down here. All right, now we're on the ground. Now we're looking up. This is the perspective of somebody who's in Adelaide looking north. And see how the sun's doing that? And hopefully you can figure out that is what the sky looks like from your perspective. I don't know how to explain it any clearer. Ronnie, if you can't hear me and you keep saying, no, but it would be going out away from you. That's what's happening. I can't explain to you any clearer. That you're only going to see this part of, you need to get a big room. Imagine a ceiling above your head and imagine that light coming and going on the ceiling when we already talked about how close it is to you. It's barely above your head. When you're talking about the entire shape of the earth and you're talking about this sky is right above us. And so you're going to see it and go. See it and go. And again, it's not a ball of gas. It's not a ball of fire. It's not like you're seeing a actual item here that is in the sky above you here. This is not what the sun is. The sun is it's rendering. I don't know how else to explain that to you. But it's just it's different for each person. And we know that because if you don't believe that, then ask somebody who believes in the globe to triangulate the sun. And they'll tell you that we don't triangulate the sun. Well, there's a reason for that. They'll say it's because so far we can't triangulate. It's so big we can't do this. It's so... No. Isn't it easier to explain that each person is rendered a view differently than somebody else? And we can actually watch that by going like this. Watch. Okay. So we know the sun's right there, right? Now, as I back up, I don't know if you can see the ground enough. Let me look it down a little bit. All right. So we can see that I'm starting to move here, and you'll see that the sun is just rendering for me. See how I move? So if we tried to triangulate this with that distance over here and this distance over here, you're not going to get an accurate answer because the sun is rendering for me. It's like as if there's a source light hitting something and then, oh, here's an excellent test. Miss and I did this. I told David and his girlfriend to do it, Paige. Take, if you don't have one, oh, sorry, get one, the little dome glass piece, put it in the middle of a table, have you and your wife sit on opposite ends, and then take turns shining lights at it and find out if you see the same thing. You won't. That it renders differently for each person. Meaning if you ask her, put your finger where the light is right now, she'll lean forward, put her finger on the dome, and it won't be where you see the light hitting the dome. So just as an example, so you can prove to yourself that it is possible that the sun is just rendering like that. Meaning it could be from a source light and each person is seeing it differently. Because if somebody's over in, let's go see if we can get down here. I want to kind of get away but still see the sun. Is that possible? Let me see if we can get up like this. Sun, you still there? Okay. Right. And then we can kind of move this way. And for each person, it's just going to be a different spot. So if we go far enough this way, it's going to be rising or setting. Right? And it's just because of how it renders to each person. There. So it's never below your feet again. This would just be like you just got further away from this person where we were before, where it was above their head. It's still above their head. It's still above your head, just distance away. And so, somebody else said, well, how does Google Earth work so bad or work so good? And it's because smart people have... here's the way you have to look at it. If you ever had a plane, and let me go back to my drawing. If you ever had a plane and you... Just think how easy it is to make that into a ball. It's not difficult. It wasn't even really hard for them. And it took them a lot of years and took them a lot of smart... Oops, you're not seeing my screen again. It took them a lot of years, took a lot of smart people. But I just don't think it's as difficult as many think. Because if this is a plane, then you would just wrap it. Let's say... Let me get back over here. Let's just say that we don't even know what this map is yet. So we have nothing. And... all we know is that oops, that's the wrong color. So all we know is we've got some continents. We got this continent and this one. and this one, and this one. Okay, so we got those 4 continents on a plane. We don't know how big it is, but we want to trap people here. Okay, we say we don't know how big this is, so we want to trap people here. That if you just took a drawing of the square, that you say, okay, we're going to rope off from here to here to here to here. Okay, so we just decide we're going to rope that off. Then what you do is, then there's mathematical equations for wrapping a plane into a sphere. You wrap it around the sphere. Now, I don't know if you guys think you would have extra, or would you have more of the sphere that you need to fill in? If you get the answer right, it's that a plane is extra. So there would be extra areas of the plane that would not fit on the sphere. And the best thing to do would be to chop out pieces of the ocean. So if you chopped out these pieces of the ocean and said, let's pretend those don't exist, then you would wrap the sphere. It would work on the sphere. And then you got smart people like Tim Osmond saying, well, how did the longitude and latitude work? How could they ever work? Well, once you have this, it's easy. It's very simple. You call this and this and that and this. You call that your 90 degrees south. You call this your 90 degrees north. And you make your lines of longitude and latitude. And this is how easy it would be to fool us. And yet people think like, it can only be a sphere. It can only be a sphere. Nothing else it can be. There's no way to trick me. You draw your longitude here. Your equator. And you have your longitude, latitude lines. And all of a sudden, what once was a huge plane for people to go around is now a sphere where they're stuck. Especially if you make this middle north. And it's magnetically north. Because then you can't go anywhere else. So you start to sail your boat this way, like I'm going to take off. I'm going to see if there's something else going on over here. Well, you can't, because your boat's going to tell you, no, go this way. Right? If you have your compass, we'll draw a compass here. If you're right here, and you've got your north, south, east, west, don't tell me I'm not. I am. Sorry, I saw my text light up, so I thought for a second somebody was telling me I wasn't on. North, south, east, west. Okay, so if you had this, then if you start to go, that north has to turn with you. North, this dot is going to stay north, wherever you're going. So there's no way, how would you travel out here? It's just going to be, it's not going to work for you, because south is going to take you here. So you're going to start to travel this way, and then south is going to take you this way. You can't even get there. That magnetically, it doesn't exist. As you start going this way, south is going to bring you back this way, because it's just the opposite of north. So it's just easy to describe how they would be able to do it. And then you would have big bodies of water where you couldn't track planes, right? These areas here, you can't track, because otherwise somebody knows they exist. So what you have to do is kind of have planes. Let's say you're going from Santiago to Australia, or Australia to Santiago. You have to have planes get lost here, because you can't, that land doesn't exist. There's no such thing as that land. And then you have planes fly across, and if they get up in some jet streams and move there pretty quick, then the only way anybody would ever know is the person who designed the map. Because anybody else would assume that the plane is getting there, that it must be, if this is, say, 7,000 miles, okay, to go that distance. Here's 7,000 miles. That if you get there in a certain amount of time, then you would just divide that by the time. And that's how you get how fast you were going. So if the plane was going 610, well, then the plane was going 610. That's how you figure it out. But if this is actually 9,000 miles, then it's a different story. But nobody would know this. Not the plane, not the pilot, not the air traffic control, because this does literally not exist. There's nothing that's happening here. The only way you would know it exists is if for whatever reason the plane was getting there way late. But again, if they can get the jet streams, and again, I have to do a video I've seen Jim Fetzer talking about this, and people don't seem to get that if you believe that those planes are proof of the globe Earth, well, then you're not thinking, because if those planes are going what they tell us, then they're not taking advantage of, they go about 620 miles per hour or so. And the jet streams out there are 150, sometimes 200. Oh, that's what I was going to look at too. Sometimes 150. So let's say they're 200. Okay, so that means the plane should be going 820. Okay, the jet stream is carrying the plane that way. And no, it's not over the sound barrier. I've talked about this many times. The sound barrier is you going through the wind, through the air. And if there's a jet stream, then the whole thing is being carried that direction. So you can get 820 miles per hour, or you're going 420 miles per hour and not taking advantage of any jet streams. You're just coasting. This is what you have to believe if you think that those flights prove the ball Earth. And you think planes that could be getting there much faster just don't want to. That's just cruise speed for this 11.5-hour flight. We don't need to get there. No one's in a rush. Okay, let's go look at one thing real quick, and that is the, where is it? I wanted to show this, and Earth Global Map. Okay, we're going to look at earth.nullschool, if I can find overlay browser, transition. Okay, so this is earth.nullschool. I'm sure many people have seen this before. Come here. Now, if you remember, you used to be able to go to, and look how ridiculous these winds are and everything. You used to be able to go to AE and it would immediately change to the azimuthal equidistant map. Now what does it do? Changes to an azimuthal equidistant, but puts Antarctica in the center. Believe me, if you think that's just a coincidence that the owner of this changed it for some reason, go ahead. Believe that all you want. So we can drag this out. We'll get the Antarctic to go around the outside. Then I try and get the lines as straight as possible on the edges, the longitude lines, latitude, longitude, there. Okay, so I'd say that's about correct. And lots of different things that you can look at here. We're going to go wind and, let's see, what's neat. So, it's usually between this and this, like I said before, but this is at 250, which is like 35,000 feet. And punch in here, look at 242 kilometers per hour. How about that out there? 136. Oops, what did I do? Shoot. Hold on, I broke it. There we go. So you've got somebody flying from here. They're just able to get up in these jet streams. 253 kilometers per hour. Okay, 268 kilometers per hour. So they're not taking advantage of any of this. They don't care. They're just traveling 420 miles per hour, ignoring the fact that the plane could get there twice as fast. And that's the truth. That if they're going 420 and could be going 820, they could be getting there twice as fast, and they're not. Or you have to believe the plane is going much further than they tell us. So don't need to tell you which one I believe or which one makes more sense. Clearly, the one that makes more sense is that they're lying about that distance. And that's what you would do if you were trapping people on a sphere, but you lived on a plane. You would have to get rid of land. You would have to get rid of surface features. You would not get rid of actual land. And if you did, then you could hide it from people. And I've heard a lot of interesting theories about Greenland. Think about that idea. And these are things I throw out there because, maybe people have done some research and I could say something. They're like, oh my goodness, now that you mention that. Think of Greenland, which in all the old writings is described as Greenland, like the name says. A lush green place. And now think of Greenland as we are given it. And it's completely whited out on the globe. Maybe we can go check that out. Is there anything else I wanted to show on here? I wanted to show those. Just how everything makes sense on... Let me go to ocean here. The way that the currents make sense, the way that waves make sense, the way that... let's go back to the air. Okay, and that's... Because they got all kinds of little things you can do here. They have wind, they have temperature, they have relative humidity, they've got wind power density, precipitation. This is the convective energy, and Bob will know about that one. And this is precipitable weather. This is total cloud cover. This is mean sea level pressure. Does this make sense on a flat Earth? You bet your bottom dollar does. And this is the misery index, which is where it's the hottest. Wonder if that makes any sense. And let's go to wind. Or let me see. Do I want to do temperature? Does temperature make any sense? That it's the hottest here, coldest here. Why wouldn't it be this here? Why isn't it purple in the middle? Why is it just purple on the outside? It's a globe. It's the same thing at both ends. There is no difference. In fact, the sun is 3 million miles closer to this. And yet, people still want to argue. There's no proof of the flat Earth. You have no evidence. Yeah, every bit of evidence we have is dismissed by people with words. That's all they have. They have nothing. There's no pictures of Earth. There's no proof that it spins. None of it. Zero. And yet, people want to still argue rather than just turn and look at those who have lied to us and demand that they prove it. And they would be over in a week, a month. If as humanity we just said, hey, what does it hurt to ask people to prove their bullshit? What does that hurt us? If they prove it, then we say, yeah, see, told you flat earthers, you guys are idiots. No, instead you guys want to act like you're cool, and let's just call them idiots before we even check anything. Well, enjoy your slavery. Don't know what else to tell you. So, something like this is the air currents. Again, let's look down here. Let me scroll this. So see if this makes sense. You've got a sun and a moon going this way, okay, which is going to cause things to go out this way, like the Coriolis force, right? You have the sun and moon going this way, which is going to kick things out this way. Everything's going to go this way, and as you go this way, look at this stuff. This stuff's all traveling this way. So you're getting that current. Now you got things on the inside going off to the right, which is exactly what the Coriolis force says. Things going this way are going this way. Oops, why did I do that? Those aren't very straight. Okay. There we go. Everything on the outside this way. Everything on the inside this way. Does that make more sense, or does this make sense? Let's really look at this. Remember, the Earth is spinning this way. Spinning to the east. And all the wind goes east. What? What causes the wind to go east? The spin? The spin's going east. And actually, the spin is where we at right now. We're about, probably even up higher than that. We're probably like that. If the sun's on the other side, I'm putting the sun over there. And the Earth's spinning this way, and it makes no sense. Makes no sense. Earth this way, then the wind would go this way. Earth spinning, wind. And if you haven't, I know you haven't heard it yet, but in a couple days there's going to be a debate that Dave Weiss and I had with some scientists, and a guy from NASA, a guy from SpaceX, and they were stumped on this one. They could not. They told me Coriolis force. I said, you can't. That's not an answer. When I ask you what's making these winds go, this wind is going 200 miles per hour faster than the Earth spins. 236 kilometers, 86 kilometers, 123, 247, 177. So it's going faster than the Earth spins in this direction, and his answer is Coriolis force. How could the winds move faster than the ball is spinning? Coriolis force. No, I don't think that's a good answer. It doesn't work. If they're going this way, then the wind should be blowing that way, not the other way. So, just wanted to show you that ball.